Time for another fun day. Doing 6.2 Properties of Parallelograms. So special. So special, the parallelograms. I'm sure you got the property, or you got your title here. Just to let you know, our objectives for today are to use the properties of parallelograms, which I don't know about yet, but that's the point of today, right? Take the smartboards off, it's going to be fun. Alright, anyway, what's the difference between these two shapes? Give me a hint. It's in these two words right here at the top. Convex, concave. Looking at these pictures though, what do you see? You see something different between the two? This one kind of points in. It's like kind of like I sat on the top of it and it just flattened down inside. Dang. That's because one is actually called convex, one is actually called concave. Usually I hit this and it goes away. Super. Obviously I'm doing my job well here. Convex, concave. Concave means to cave in. Alright? Shape points in towards the south. So here's your definition of convex. A straight line drawn through a convex polygon crosses at most two sides. So what that means is when you're drawing, anytime you draw any line, you shouldn't at any time ever intersect more than two sides when you draw a straight line. So no matter where I draw a line here, I'm only intersecting, smartboard's off. I'm only intersecting at 2 points. Concave here, if I draw this line right here, look at that, that's 1, 2, 3, 4. 4 points that it intersects, and that's at any point. I could draw a line down here. Well, if I draw a line down here and try to say, oh, well, this is convex, because look, I drew that. Well, no, it's any point where you can have a line. I think a concave is caving in, pushing in towards the south. For some reason, any part of the polygon points in towards the south, you got concave. And here's our concave definition, which is goofy, should be over here, but whatever. Concave, you can draw at least one straight line through a concave polygon that crosses more than two sides. At least one interior angle is more than 180. That's another way of looking at it. We have at least one angle here that's more than 180. Look at that angle right there. Coming on the inside, it's definitely more than 180, right? Straight line. Another one bites the dust. Alright. We talked about this a little bit yesterday, but the interior angles of the quadrilateral, they add up to 360 degrees. And I got visitors, it's gonna be office. But I'll let you copy that for a second. Alright. Come in quietly. No editing here, I'm just going to keep on rolling with this. Rolling with the punches. Alright, next page. Alright, so parallelogram, you're probably wondering, what is a parallelogram? Parallelogram. In the short writing as well, feel free to start, well, after you write parallelogram. I don't want you to start using the shorthand immediately, but you would also actually draw two parallel lines here and write gram. And then we know it's also a parallelogram. Another way to do it. When I know, I put it on this. Jesus. I don't know what that means. Don't freak out, it's going to come back and then, oh my god, I did the right thing. Know you guys too well. Alright. So a parallelogram is a quadrilateral with two sets of opposite sides parallel. So you can see here, AB is parallel to CD, AD is parallel to BC. Two sets of sides parallel. So there's a lot of special things here. Let's you don't have to draw all three shapes, just draw one of them, two of them. You get the idea. These hoodlums are going to come walking in here all loud, watch. Oh, okay, they're coming in quiet. Good to go. You guys want to make a cameo real quick?
No.
No? Alright. Worth a try, right? Alright, so we have special properties of a parallelogram. And what we're trying to say here is, if you know you have a polygon that is a parallelogram, and then you know what? Feel free to draw that lovely shape here. We're going to go with all of our properties. As you can tell, we have 4. I better click this. This better disappear. I'm a little crazy. Oh, come on. Alright. Haha, there we go. We're good to go. Back in business. You can use the laptop if you want.
It's not working.
Pause. Alright, so first thing, opposite sides are congruent. So if opposite sides, let's not forget here the definition, opposite sides are parallel. If we know we have a parallelogram, we know that the opposite sides are congruent. Also, opposite angles are congruent. They're making things weird over here. Alright. Opposite sides are congruent, opposite angles. That means that angle A is congruent to angle C, angle D is congruent to angle B. Opposite sides congruent, opposite angles congruent, opposite sides are parallel. It's the definition from 2 theorems. Another special property. This one's going to sound a little quirky, but consecutive angles are supplementary. What we're trying to say here is the angles that are next to each other, the adjacent angles. So, angle A plus angle D is equal to 180. Also angle A and angle B. The angles that are adjacent to each other, the angles that are next to each other, are supplementary. Angle A, angle D are supplementary. Angle A and angle B and angle C and angle D. The angles that are next to each other, supplementary. They're adding up to 180. So, parallelogram, opposite sides are parallel. That's the definition. We have opposite sides congruent in a parallelogram, opposite angles congruent, and consecutive angles are supplementary. Last but not least, you have to be wondering, well, what's up with these lines here in between, cutting in between those diagonals? Diagonals bisect each other, cut each other in half. Which means that AX is congruent to CX. And DX is congruent to BX. 2 little parts here are congruent to each other. Now we're going to try some example problems. I can tell you, there is something more awkward than sitting in a classroom by yourself, recording yourself doing notes. It's doing it with 2 students that are sitting in the back, not paying attention. It makes it even more awkward. That's right. And they're still quiet. I was trying to get them to make people, but no. Oh, now they're getting frustrated. Jen Robinson is giving me looks. That's right. With her reading glasses on. She's straight nerding it right now. That's besides the point. Let's get back to our math. Even in the videos, it'll be wasting time. Alright, so we want to solve for x here. We gotta be thinking here, we got angles, we're given angles, so we have to be thinking about our special properties for the angles. What are the 2 special things we talked about with the angles? Oh, the opposite angles are congruent. Yeah, that was right, angles are congruent. Are these opposite angles here? No. Shucks. Second thing was consecutive angles are supplementary. Yeah. Are they consecutive? Yeah, they're adjacent, they're right next to each other. So they're supplementary, so let's set them supplementary. Oh. That one. That was a special one. Won't get into it. x plus 30 plus 120 equals 180. This board is way, I should have done something about it, but I'm already too engaged, in too deep. So x plus 30 plus 120 equals 180. These angles are supplementary. 30 plus 120 is 150. So x plus 150 equals 180. We have to combine our like terms here. So x plus 150 equals 180. We need to get x by itself, right? We need to isolate that bad boy. So let's subtract 150. Let's get it out of here. What's 180 minus 150? 30. You solve for x. Wham bam, thank you, ma'am. Now we got this bottom problem. We're given three sets of things here. We got 6x minus 30, we got 4x plus 30, and we got 60 minus 3x. Hills is throwing some curveballs at you. Let's think about the sides. What do we talk about with the sides? Well, we know opposite sides are parallel. We can see it's a parallelogram. It's marked as that. So we know we have a parallelogram. We know opposite sides are congruent. And we know the diagonals bisect each other. We don't have any diagonals here, so we're thinking opposite sides are congruent. What are our opposite sides here? These are opposite sides. These are opposite to each other, so they're congruent. This guy, obviously, maybe not obviously, this guy here, though, is just there to trick you. We don't even need it. Because it's not opposite of one of these two are opposite to each other, so we're going to set these two equal. So unless we wanted to find out what the length of that side was, which we can use, but we don't need it. This is what we need here. So 6x minus 30 equals 60 minus 3x. I'll let that just sit in there for a second. Better stay off my corn nuts. Yeah, we got these. And now she's going to open them. Alright, so 6x minus 30 equals 60 minus 3x. Add 3x to both sides. Add 30 to both sides. Let's just redo it. Let's take it nice and slow. Those will be jumping, going crazy. So we're going to add 3x. We want to get our x's on the same side, right? So to do that, we've got to cancel out this 3x. We'll bring it over to here. 6x plus 3x is 9x. Oh, there's the little dent. So now we have 9x minus 30 equals 60. 9x minus 30 equals 60 because we added 3x to both sides. We're going to add 30. 60 plus 30 is 90. We got to bring our numbers to the other side. We got to bring our constants to the other side. We have x by itself. It's almost there. Problem is it's being multiplied by 9, so we have to do the opposite of multiplication, which is division. Great. Divide by 9. Divide by 9. X equals 10. Great. Giggles. That's all getting recorded.
You weren't in the camera thing.
I moved out of the way so they can see it.
Oh.
Oh, this is awkward.
Geez.
I'm sure there's enough time here for you guys to write this. Hopefully it wasn't too much of a distraction. Time for class. Won't say the name of the person now. Thanks for letting me know that was out of camera. Alright, so here we are, looking at another two fun problems. Ooh, this one. This is going to be a doozy. Well, let's get over this guy first. Alright, so we're given angles again. Got these two angles. So we got to review what we know about the angles. Opposite angles are congruent. Consecutive angles are supplementary. What kind of angles do we have here? Are they consecutive? No. Are they opposite of each other? Yes. So we know that they're congruent to each other. Means that they're going to be the same measurement. 4x minus 12 equals 72. Equal to each other. Opposite angles are congruent. So equal in measure. So we add 12. 4x equals 84. It's 4 times x equals 84. So the opposite of multiplication is division. Divide by 4, divide by 4. X is 21. Money. I might even skip this last one. I don't think I'm going to give you any like this. I'm just going to show you the setup. But I'm not going to actually have you do anything. This is a system of equations problem. You're like, what's that? Well, you should have done it in algebra 1. But it's alright. So, here we're given the diagonals. And what is special about the diagonals? The only one we haven't talked about yet with any of our example problems. So the diagonals bisect each other. They cut each other in half. So that means that x is going to be equal to y plus 2. Right? Y plus 10 is equal to 2x minus 8. Two different equations. Now you're saying, well, what the heck? I got an x, I got a y. Alright, let's just solve it. It's going to be fun. I may not give this to you in your homework. I might probably just try it out, but probably won't give you anything like this on quiz. Probably. You never know. I'm crazy. I do crazy things. So, x equals y plus 2. Well, we know x is equal to y plus 2, right? So why don't we take that, plug that in for x, right here. We're going to plug y plus 2 in. Now they're arguing in my video. I'm sure it's in there. Ah, Jesus. Alright, so y plus 10 is equal to 2 times y plus 2 minus 8. Now we're going to be able to solve for y. So y plus 10 is equal to 2y plus 4. We got to distribute, right? Got to distribute that bad boy in there. And that's minus 8. We got a plus 4 and minus 8. Let's put those together. Y plus 10 equals 2y minus 4. Combine our like terms here. So we have y plus 10 equals 2y minus 4. Let's get our y's to one side, subtract by 4. I'm going to extend this page, give us a little room. So subtract y from both sides. 10 is equal to y minus 4. Now what is that, our 4? Y equals 14. Are we done? Nah, we didn't get x yet. So in our original equation, we said x is equal to y plus 2. Give me a second to think about this one first. Let's look at all that beauty that we did. Isn't that beautiful? That's just freaking beautiful. There you don't see the people in the back, but they are agreeing with you. They're saying, wow, that is beautiful. It's like a work of art. Mr. Budden should be up here right now saying, wow, that's art right there. You know what I'm saying? Alright. So y equals 14. We can plug that back into this equation. We can plug it into either equation, really. This is a smaller one. This is just y plus 2. We plug that in. X is equal to y plus 2, right? Plug in 14 in. So x equals 14 plus 2. 14 plus 2 is 16. Like I said, I might not give you this kind of problem. I mean, you might get some in the homework, but I'm not going to have you do a lot of these kind of problems. The system of equations are kind of tricky. You should know how to do it. It was in algebra 1, but yeah. Look at that. All that work. Doing work. Woke up this morning. It's work time. Alright, moving on. 367. It's a lot of craziness, but I'm going to try to simplify it for you as best as possible. I'll give you a second to write it down. Another one bites the dust. Alright. So, a lot of words here, a lot of crazy things you're saying, but let's just go over the basics here. So I'm just going to tell you the general definition, simplify it. If 3 or more parallel lines cut off congruent segments to one transversal, so these are 3 parallel lines cutting congruent segments, we have congruent segments here, of the transversal, then they cut off congruent segments on every transversal. Alright, so what we're saying here is AB is parallel to CD is parallel to EF. If these three lines are parallel, and you have a set of congruent segments here, so AC here is congruent to EC. We're given that information. Then we know that the opposite sides are congruent. That's what this picture is showing here. Then BD is also congruent to BF. We already know AC is congruent to EC. You know, these two are congruent to each other. With these parallel lines, got the transversal. These two parts are congruent to each other. That means, hey, if we draw another, we have this transversal here being drawn, these parts are congruent. If I draw another transversal, I'm going to have to intersect with it. If I draw this transversal here, guess what? This is congruent to this. I can draw 100 transversals. Knowing that these two are congruent here, if I draw any transversals I want, no matter if I draw it crazy, at an angle crazy like this distance will still be the same as this distance. Always going to be true. Mind's blown. Alright, let's click this thing that says Clickarooski. Sounds like a lot of fun. Oh man. There goes Hills giving us a fun problem today. Let's see how that looks on camera. Oh, that looks beautiful. Look at that. Just like that, we're 20 minutes in. Alright. So in the figure here, we have AE parallel to BF, which is parallel to CG, which is parallel to DH. These four lines are all parallel to each other. We know that AB is equal to BC, which is equal to CD. And that's all equal to 2, which means this is 2, this is 2, this is 2. We know that EF is 2.25. They want to know what the length of EH is, this whole big dog. Since these lines are parallel, we have this transversal here. All these are 2. These are all the same length. That means that these parallel lines are all equally distant from each other. Any line that we draw, any transversal that we draw through it, are all going to have equal parts of their segments. So if that's 2.25, this is 2.25. This is 2.25. All three of these are 2.25. So what's 2.25 times 3? Or another way you can think of this is if I have $2.25 and I get that 3 days in a row, Hills ain't giving you $2.25 each day, but let's just think about it like that. $2.25 each day, and we get $6.75. You can let him in. You just gotta be quiet.
It's just Leah.
Oh, it's just Leah. So, what I'm going to propose to you is tell me 5 things that you learned about the parallelograms today. AKA, what are the 5 special things that you know now about parallelograms? Think about it. Take a second. Bye.